How are you, Mr. Taylor? Hello, Taylor. How are you?
I'm fine. How you doing?
Good, good. We're still waiting for some people to join, at least to get to 3 or 4 people to join in, then we can begin.
Okay.
Looks like everybody's late today.
It looked like the message had said class for tomorrow. So when I saw the message, I double checked, but it does say class for today. The text message said class for tomorrow, but the announcement said class is today.
The message I sent said class tomorrow. Oh, I see what you mean.
Yeah, so when I went to the announcements to double check, it did say classes today.
Okay, let me send another message. Isaiah. Just another one. I thought I wrote today. Okay, one person joining now. One minute, let me send this again. Okay. Let's see it now. Today, not tomorrow. It has started. I'm going to join so I can mark the attendance. So I've sent it again. Okay. So we can begin. I think I'll have somebody else join us. We have Chadone. Chadone, how are you? Chadone, you there?
Yes, sir. I couldn't hear it. I had to move.
How are you doing today?
I'm fine. How are you?
I want one more person to join, at least so that it can be at least 3. Then others can join later. You know. So just 5 more minutes. When we 3 more minutes wait. Then if nobody joins, then we can start. Oh, somebody else is joining us. Okay. I think we can begin now. So today will be, last week we completed a normal distribution. Today we'll start something new, which is called confidence interval. We finish it today, and then next week we'll just see how next week goes. Next week is the Thanksgiving week, I believe. We'll see how it goes. I will let you know if we are going to have a class or not. But usually, Thanksgiving weekend, there are usually no classes. Okay. I will let you know if anything changes, but I doubt that it will change because it has been like this for a long time. Every Thanksgiving, usually we don't have a class. They normally call it the Thanksgiving weekend. Now, that's what we're going to be doing. But please, when you have the chance, check my announcement in Canvas. In that announcement, I explained where you can find this handout in the file section. Also, you will see the assignment that are due. We don't really have anything to do this weekend. So, well, you have something to do this weekend, the quiz that was I put there last week. But other ones are due the 29th. I usually encourage you guys to start on time, so that you can finish time. We don't really have much time left now because after the Thanksgiving weekend, 2 more lectures will enter the exam week, final exam week. So please try all you can to finish them by the exam the homework that I put there by due date. So them are due on the 29th. So them are due in December. Okay. So always check my announcement. So we can begin now. Confidence interval for the mean. We also have confidence interval for proportion.
Professor, when is the last day for this class? Do you know?
I think I have it on the syllabus. Should be around 13th December.
Yeah.
But I will send the message. I will double check and send a message in Canvas so that you know. Okay. But last time I think it was 13th of December. Then we enter the final exam week. Okay.
Okay, thank you.
So after the class, I will check.
So it's not like the 13 doesn't include the final exam and all that.
So first of all, the lecture will stop. Then there'll be a week for the final. So Mr. Owusu, it looks like something. Can you mute yourself at the background so that
I muted myself.
Okay, good. I will still have some voices behind, so can double check it again. Now, so for confidence interval, we also have confidence interval for the proportion. But we're not going to do that. We're just going to do confidence interval for the mean. Then we can now do test of hypothesis. Now, what we do in confidence interval is we try to estimate the population parameter. In this case, it is the mean that we are trying to estimate. I'm going to make this bigger. Make it a little bit bigger from here. So let me give you this background information, then we can start working on it. So it is basically an estimated range of values that includes the unknown population parameter. When we talk about population parameter, we're talking about mean, standard deviation, or proportion or percent. But like today, the one we'll be working on is only the mean. Now we know we have what we call the point estimate. The point estimates usually give us a single value about the population mean. For example, a local bus driver, can claim that the average price of gasoline in 2008 is $2.34 per gallon. Just one number. Or somebody like a CEO, like I used a Ford CEO, can claim that on average the company produced 200,000 cars in 2013. So you see one number. Now, but we're not interested in that. But I have to say this: the best point estimate of a population mean is always the sample mean. So what it means that we use the sample population to estimate the population proportion. The population mean. We use the sample mean to estimate what the population mean can be. Nobody actually knows what the population mean can be except Providence, but we try to make an estimate that is as close as possible to it. Now, so the best point estimate is always the population mean of the sample of the population mean is the sample mean. Now, this is where we are interested in here, the interval estimate, where we have a range, the lower and upper range, and that's where what we're doing today, the confidence interval. So, for example, the same local bus driver can say that or claim that the average price of gas in 2018 is between $2 per gallon to $3 per gallon. So we can have ranges, prices in between these ranges. So at this time, you can see that we have two numbers here, the lower part and the upper part. The lowest price that was sold in that year and the highest price that was sold in that year. So in between those two prices, you can have ranges like $2.15, $2.50, and so on and so forth. The same way, Ford CEO can also claim that the average amount of cars they manufacture is between 190,000 cars to 250,000 cars. Again, we have two numbers, the lower part number and the upper number. And in between them, you can have different ranges of numbers that shows the mean. Now, there are some few terms we need to know before we start doing work on confidence intervals. First one is the confidence level. In that case, we say that it tells us kind of how the likelihood or the probability that the sample mean or that the mean of the population is what we say it is. So in that case, nobody's 100% sure. So we have to assign a percentage to it, a probability to it. So, for example, we have three confidence levels that are very popular in statistics: 90% confidence level, 95% confidence level, and 10% confidence. So you can say you are 90% sure that the average amount of cars produced in 2013 is between 190,000 cars to 250,000 cars. So if you say that you're 90% confident, that means the chance of being wrong is 10%. See? Somebody can say that they are 95% sure, not 100%. The only person that can be 100% is Providence, because of human error. So if you say that you're 95% confident, that means your chance of being wrong or being incorrect is 5%. Now this one, 99%, this is one that's being used by the pharmaceutical industry, because it's very popular, because you have to be sure that that medication on average does what it is supposed to do. When you look at the clinical trial for COVID-19, you see that they have been having this vaccine for a while, but now some of them are saying that their vaccine are 95%, they're 95% sure that the vaccine will prevent flu. You see what I'm sorry, not flu, COVID-19. You guys have been listening to news, right? Seeing all this, they have 3 vaccines. One from one company, Moderna, say that their own is their 95% effect. Their vaccine is 95% effective against COVID-19. There's one that says it was 94%. That one came before that. I think I forgot the name. I think Pfizer said that. So these are the confidence level. The only person that can be 100% confident is, like I say, is the Providence. And we use it to estimate the population mean. Next thing we need to know is the critical value. We use this symbol to represent it. We use Z alpha over 2. Alpha over 2. Why alpha over 2? Alpha actually represents the confidence level. I'm going to tell you how it works. For example, if you're 90% confident, your alpha will be 10%. That is 0.1. Why? Because your chance of being incorrect is only 10%. See, that's your alpha. Now, if you say 95% confident, your alpha will be 5%, which is 0.05, because your chance of being wrong is only 5%. That's how it works. If you say you're 99% confident, that means your alpha is 1%, that means your chance of being wrong is 1%. Now, we're not using for confidence interval, we're using, because remember, it has 2 sides, the lower side and upper side. So we're using alpha over 2. That's why we have this symbol for the critical value, Z alpha over 2. Why Z? Because we'll be using the standard normal distribution table. The Z table. Let me show you. I think we used it last week when we were doing normal distribution. It is still the same table. Let me share it with you. And remember, I also have it in the canvas. Just check my announcement. You see where I explain where it is located. You can see it right here, the standard normal distribution table. You can see the Z right here. Okay, so that's why it says Z. And because of the 2 sides, we use Z alpha over 2. Okay. Now, questions before I continue? Any questions? Okay, good. Now, since there's no question, let me show you how we get this critical value of Z alpha over 2. That means a numerical value that represents this alpha. So it is on the show the borderline, supporting the sample statistics, right? That's where it's likely to occur. So let's do an example how to find critical values. I'm going to show you with these examples here. It says, now, why do we need it? We need to find the critical values Z alpha over 2 before we can estimate the confidence interval. The first one we're going to be doing, we can do any of this, but let's see how it gets numbers come about. Say, look at it, say find the critical value Z alpha over 2 corresponding to 95% confidence. Now, because I'm going to be using this number in the table, let me just change it to 90% so that it will be what we are working on, 90%. Okay, confidence. So solution is, so that tells you a solution. We'll have it here. Solution. Says Z for 90% confidence. We have to find the Z alpha over 2. Because of the fact that we don't have the formula page character for sorry, I cannot put the formula here because it won't let me here. So I'm going to take you to a new page where we can put the formula. Then we'll come back here and finish the work. Okay. So it says Z alpha over 2 for 90%. Now, remember, percent is over 100. But because we have 2 sides, lower side and upper side, I'm going to show you a shortcut method for finding the critical value. The other method you can use, but let me use the shortcut. The shortcut method is P over 200. And then you find the result in the table. Why over 200? Because two sides. Otherwise, percent is over 100. But that is actually a shortcut method that works all the time. So let's do it for the 90% confidence. I'll take you to that page, that workbook. So we're gonna, the formula is this: Z alpha over 2. We got Z alpha over 2 critical value. Okay. Excuse me. The critical value which is Z alpha over 2 for 90%. Z, let me make it bigger so that you can see it very well. Z alpha over 2, alpha is right here, over 2 equals P over 200. P over 200, where P represents the confidence level, and 200 because of the fact that it is both side to side. Now, this is a shortcut formula method, and that gives us, because we are working on 90%, that means 90 over 200. So whatever answer, now let's get this from the using our calculator, the Desmos. I have this here. Let's go. Desmos, I have to open it up because I have not opened it up yet. It's right here. So I have Desmos. It's a free scientific calculator that you can get online. So I got 90 by 200, 90 by 200, 90 excuse me, divided by 200, give me 0.45. Now, in the table of Z table, the numbers are four figures. So 0.45 means 0.4500. So let's put it up over there in our workbook. 0.45 4500. Now to get the critical value, now we look for this number in the table, inside the table. If we don't see it, we choose a number that is closer to it. Sorry, closest to it. And that will be our critical value for Z alpha for 90%. So let us do it right here. We'll look for the table right here, 4500. We start looking inside it, not on the side, this is inside. I got 4505. There are two numbers closest to 80, 4595 and 4505. Both of them are equally close. How do I know that? If you write, we have 4500. So 4500 minus 4495. I'll show you the Desmos. Give me 1 minute. Let me get this again. Write it down. So 4505, we have 4500. That's what I have. And then let us check this first one. Say 4495. It's a 4495. 4495. Now, when we subtract them, we see that it is only 5 points. So we have, okay. Can you see the calculator? Hello? Miss Stella?
Yes.
Okay. Minus 4495. 95. It is 5 points away. Now, if we check it with the other number we have, because there are two of them that are equally close. The other one is 4505. See, let's check it. See, let's go to calculator. We have 4505. 4505 minus 4505. 0.00. It is also 5. So they both, two of them are equally close to that number. So what we do in this case, we choose the one that is bigger, which is 4505. This one. Now we follow it to the left, 1.6. Okay, and up 5. So that means the z alpha over 2 will be 1.65. See, follow it to the left, 1.6, up 5. See, that gives us a critical value of 1.65. So have it here, 1.65. 1.65. Now copying it and then paste it in our the main workbook, which is where's the main workbook? It's somewhere it disappeared. Okay, it's right here. Okay, so this becomes our critical value z alpha over 2 for that number for the 90% confidence. Make this bold. And as you can see on the table, I have it here, 1.65. Any question on that? Any question? See, it's right here. The same thing we have. So
No
that's
question.
how we, yeah, go ahead. Have a question?
I was just saying I have no questions.
Oh, okay, good. Now, the same process. Now, like I said, this is one way of finding it. The other ways you can do it. Let's try one more for 95%, so that you can get a picture. Usually, we provide you with the z alpha over 2. We give it to you. But in case if the equation doesn't give you that, then you can know how to calculate it. Let's try for the 95%. So I can change this to 95%. If you like, I can use 99%. It doesn't matter. It's still the same. Sometimes you will see the number exactly the way it is on the table. And then, so the solution is here. Okay. Solution becomes, so again, 95%. The shortcut is P over 200. So I'm going to take you to the other workbooks where we can put in the formulas. So this is this workbook right here. So you have the 95% critical value, P over 200. In this case, it is 95%. 5%, which is, let's look at the calculator. This 95 over 200. 95 divided by 200. Okay, clear this. 95 by 200. 0.4750, because you have to be 4 digits. So 0.4750, 0.4750, 0.4750. Now, with that, we can now go to our table of normal distribution to find out what z value correspond to this. 0.4750, we go to the table and look. 0.47 inside here, you can see it right here. 0.4750, we pull it to the left. 1.9, and pull it up. 6, so 1.96. We got that as 1.96, 1.96. Then we can copy it and then paste it in our main workbook. Okay. Our main workbook is right here. It keep disappearing on me. Right here. So then you can see that from the table that we have that it is 1.96. So 1.96 is the answer. And when you go to the table up, you can see that for 95%, it is 1.96. So that's how you get it. Now with this background, when you get a chance, you might try number 3 by yourself. So if the question asks you that, especially in the homework, you can know how to get it. If any question before we now begin the actual calculation of confidence interval for the mean? Okay. So since there's no question, you can then begin the calculation of the confidence interval for the mean. So let me make it bigger, bold. There are two things we need to do. The first version we do is when the population standard deviation is known and sample size is large. Statistically, we say the sample size is large when it is bigger than 30 or more, so long as they are randomly selected. So that is the first version of confidence interval for the mean that we're going to do. The sample size is large, and then, and the population mean is sample size is large, and the standard deviation is not known. So let's do one example here. It says here, a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation is 15. Find the best point estimate for the mean. Find the 99% confidence interval for the mean reading scores, and find the 99% confidence interval. Okay. Now, so let us do it. Part A, solution. It says here, find the best point estimate. If you remember my first statement at the beginning, it said that the best point estimate of the population mean is the sample mean. Here, it said a sample of 35 fifth graders has a mean of 82. So this is the sample mean right there. And that answered the question. So the answer becomes sample mean, which is 82. So find the best point estimate. So best point estimate equals the sample mean of 82. I answer that here. That is for part A. Questions? So no questions. That's good. Let's do part B then. This part B and part C are where we do the actual work. Solution. So this one, it says, remember, it said that a sample of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Now it says, find the 95% confidence interval for the mean. Okay. So for this reading score, for this fifth graders, you say that how many of them? 35. So our N is 35. I'm gonna change this to small, but this is sample. Then, and say that they has a sample mean of 82. Sample mean doesn't have a character. Like the character for the sample mean for the X bar is not here. So I'm gonna get it from the other workbook and put it back here. Sample mean is 82. So let me go and get it. The sample mean is 82. You have it at X bar. X bar, it should be X bar equal 82. So I'm gonna copy this and paste it at our work. 82. Okay. So I'm gonna make it a little bit so you can see it properly. Okay. Then the standard deviation is 15. We have that the standard deviation is 15. So for the standard deviation, the character is here. So I'm gonna just put it in. We have the standard deviation of 15. Of course, 15. Always change to that delta symbol. So let me take it back to where it's gonna be is 15. So making it big, so we can all see it properly. Yeah. Now we're looking for the 85%, 95% confidence interval, so that our Z alpha over 2 at the critical value Z alpha over 2, alpha over 2 We have alpha over 2 equals, we have it from here. We have done the calculation before, but you can have it here is alpha over 2 is 1.96. This is the one I showed you how to calculate 1.96. 1.96. So next thing we need to get is the error margin. So I'm going to move this to the next page so we can have enough room. Okay, the error margin. So the margin of error, remember when I said that if you are 95% confidence, I mean your chance of being wrong is 5%. So that 5%, the error margin we are going to estimate. The formula is, since I can't, this page can allow me to put the formula directly. So I'm going to put it on the other page. Let me write it down, then I'll put it there. Z alpha over 2 times standard deviation over root n, which is 1.96 times. Don't worry, I'll put this on the screen. Let me write it down so I can look at it while typing it. 15 over 35. Okay, got it. I will take you to that page, put them in them. We complete the calculation, bring them back here. So we have, let's find the error margin. So take it here. The error margin E. Error margin E equals Z alpha over 2. Z alpha over 2. The alpha over 2. Okay. Times standard deviation over root n. Our standard deviation is over square root of n. And which will give us, when we plug in our numbers we have for all this, for Z alpha over 2, we have 1.96 times, okay, the standard deviation, we have the standard deviation as 15, and we have our n as 35. If you remember, this we can plug into our calculator in Desmos. I'll go to Desmos. So we have 1.96, 1.96 times standard deviation of 15 divided by square root of 35. And that will give us the error margin of 4.9695. So we run to 2 decimal places, that means 4.97. So we go and put it back there in our working paper, 4.97. 4.97. I believe in 1 minute. Let me check this here. 1 minute. Yep. 1 minute. Let me check this here. Yep, 4.97. So we're gonna copy this. Once you have your margin of error, you have finished you're almost done with the question, the problem. Because it's that margin of error, you subtract it from one side on the left side and add it on the right side. That will give you the confidence interval. Okay. So now we have the margin of error as 4.97. So the 95% confidence interval is given by the formula. So on the left side, you subtract 4.97. On the right side, you add 4.97. So let me put the formula in. Get the formula from the other workbook and put it back here. X bar minus error gonna be X bar minus error. It's less than the mean we are trying to estimate, which is population mean Okay, then it's less than X bar, okay, plus error, plus error. So you add error, you subtract error on the left side and add error on the right side. That will give you the range you are looking for. So you have it right here as X bar minus error, okay, less than the mean. So now let's put the numbers in. Our S bar is the sample mean of 82, have 82 minus the error of 4.97, less than the mean. Okay. Then less than again, have, let me format this better way. Okay, this is the mean, population mean we are trying to estimate. S bar, which is 82 plus 4.97. So on the left side, we're gonna do this on the decimals. Okay. Say 82 minus 4.97. Let me write it down. 82 minus 4.97. Okay. Then I'll take you to decimals. So we have 82 minus 4.97. That gives us 77.03. Then if you do the other one, plus, because one is plus, one is minus. So if you make 82 plus 4.97, we have 86.97. So let me take you back there on the workbook so we can put these numbers in. I'll give us some. Okay, here on the left side we have 77.03, less than the population mean we are trying to estimate. Oh, excuse me. Less than the population mean we are trying to estimate. Okay, and then less than, on the other side we have the 86.97. So that means the average reading score lies between 77.03 and 86.97. So now we can now conclude. Conclusion. Even some homework, we ask you to conclude. So choose the correct conclusion. Our conclusion is we are 95% confident that the average reading score for, because here, if you look at the question, what the question wants you to estimate is say to estimate the find the right here, find the 95% confidence interval for the mean reading scores for all fifth graders. So mean means average, you know that already. So that means we're 95% confident that the average reading score for all fifth graders lies between 77.03 to 86.97, you know, based on a sample of that 35 fifth graders. So that is basically what it is. Any questions? Questions?
No questions.
Oh, good. Now, so that's let's try one more example in this section. So we have a chance to try this one. Now let's look at this one, where this one involves a little bit of here they didn't give you the this is the same way. See, we did the one with 95%. In this case, you can try this, and then you can try this one and both of them. Let's do both of them. We have time. Okay. Let's find number 5 first. 5 says a study of 415 kindergarten students showed that they have seen on average 5,000 hours of TV. The standard deviation is, or the population is 900. Find 95% confidence interval for all students. And then you have this, it says, if the parents claim that his children watched 4,000 hours, would the claim be believable? Okay, let's do it. So you have, now I want to do something here. The example we did before, this one, we used 95%. So this one, let us use 99% for this one, okay? It's just to show you that you can use either or. So, solution. Okay. So now in this case, it said a study of 415. That means N is 415. I'm gonna change this to small because it's a sample. Put the solution, make it bold. 415 fifth graders. I show that they have seen on average 5,000 hours. So the sample mean is 5,000 hours. Because I can't get the S bar character here. So let me take you to that place where I can get the character. The other workbook. S bar is 5,000. So our S bar here, we have it here already. S bar equals 5,000. I'm gonna copy it and paste it there. You know. Okay. 5,000 hours of TV. Let me make it here. Now, this standard deviation is, we have the character here, so I'm going to put it in. The standard deviation is for the population is equals, it says 900. You always change to this data symbol. Let me try to put it back each time I put it. Okay. Now I have it says A part says find the 99% confidence interval for the mean of all students. Now, so A part A. So we have these three values, but before you can do that, let's put the for 95 Z alpha over 2. Z alpha over 2 will be Z alpha over 2. Alpha is right here. Over 2 for 99%. For 99%, the alpha over 2 will be, if you look at the table we have, is remember I showed you how to calculate this, is 2.58. So you put it right there, 2.58. 2.58. And then let us find the error margin. To find the error margin, we use the same formula we use on the other ones. So let me write it down here and take it to that page. It's going to be Z alpha over 2 times standard deviation over square root of n. And our Z alpha over 2 is 2.58 times standard deviation of 900 over square root of n, and it's 415. So now I'm going to put them here. I just want to write them down so I can be looking at it while typing it in the other page. So let's go to that page and I have it right here. The error margin would E equals we're gonna have Z alpha over 2 Z alpha. So excuse me, alpha over 2 alpha, right? Somewhere, gotta be somewhere. Yep, alpha over 2. Okay, times we had standard deviation over root n over the square root of n. Okay. And that gives us for the alpha over 2, we have 2.58. Okay, times the standard deviation. For that, we have 900. Square root of n is the square root of, we have 415 kindergarten student, I believe. Okay, equals. Now this we can get from Desmos. From Desmos, I'm taking you there to, let me take you to Desmos. So we can do the calculations there. So we got 2.58 times standard deviation of 900 divided by the square root of 415. Okay. I got 113.98 right now. 113.98. 113.98. So let me take it back so you can put it in and then put it in the main workbook. So I have 113.98. So let me copy this. Hold on. So once you have your error margin, you can just you're almost done, basically. So let's put the error margin here. Equals that. So this is right here. This is part A for this question. This is part A, actually. Okay, so that the 99% confidence interval is given by this formula. Remember our formula we used before? S bar minus error. Let me copy it from here. S bar minus error is less than mean, less than S bar plus error. See? And S bar plus error. Our S bar is 5,000 hours. 5,000 minus error. Our error is 113.98. It's less than the mean, the population mean we are trying to estimate. Okay, and then less than S bar plus error, which S bar is 5,000 hours plus error of 113.98. As you can see. So in one side you add, the other side you subtract, the other side you add. And that will give you the confidence interval. So this gives us from Desmos, let me write this down. 5,000 minus 113.98. So taking it to Desmos, we're gonna solve this and put the answers back in. So for Desmos, you have right here. So you have 5,000 minus 113.98. Give me 4486. 4486.02 on the left side. On the right side, all you have to do is to make it
Professor.
You can see it?
Professor.
Yes, sir.
You didn't write 4486, did you?
Sorry, it's 4886, right?
Okay, thank you.
Sorry, is that my mistake? 4886.02. Yeah, you're right. So then put plus sign here. Thank you for that observation. That's showing me you are paying attention.
No, your classes are very informative. It helps a lot.
Thank you, I appreciate 98. So now we can now go and write them down in our page. So you have it here as equals on the left side where we do the subtraction. We have 886.02 is less than the population mean we are trying to estimate, which is the mean. And then on the right side, we have upper side 5113.98. So this is where we can say with because he said 99% confidence interval. So we can say with 99% confidence that the average hours. So that's remember these are kindergarten students. So we can say that on average we're 99% confident that on average the kindergarten students have seen between 4,886.02 hours to 5,113.98 hours of TV. So let's conclude it right there. Say conclusion. Conclusion. We can say with 99% confidence that kindergarten students seen on average between 4,886.02 to 5,113. Okay, 5,113.98 hours of TV. Now that is the based on the 415 kindergarten students. Any question on this? Questions? So okay, so that's good. Now this parent here, part B say this parent is claimed that his children have watched 4,000 hours of TV. Would this claim be believable? Well, look at the range here. It says between 4,886 hours to 5,000, almost 5,114 hours. But this parent is claiming that they have seen 4,000 hours. 4,000 does not fall within this range. So the answer will be no. No, because 4,000 hours falls outside the range of bit of let me put it up, range of 4,886 to 5,113.98 hours. So that's why if it says 5,000 fall within the range, then the answer will be yes. Questions? Yeah. So no questions. So good. Now the other one here, they give you the number. And if you look at this one that we just did, they give us the mean and the standard deviation. If you look at the first one we did, they also give us the mean and the standard deviation. Now for this one they didn't. That means you have to calculate the mean by that. That is the only difference. It's the same thing. Just find the mean of these numbers. They give you the standard deviation already. Just find the mean. How to find the mean? You add all of them, and there are how many farms we have here? 31 farms. Say 31. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Then plus this one here. So 3 times 10 is 30, plus this one is 31. So just add numbers and divide by 31. That'll give you the mean. They give you the standard deviation already. Then use this to follow the same process to find the 90% confidence. Okay, so you can try that as a practice. Let's look at sample size computations. Okay, it says so usually, like I always told you at the beginning of the class about sample and population. Most studies we do, we don't use the entire population, unless we are doing a census. If you're not doing a census, we use a sample. If you look at the clinical trial that was done by, or it's an ongoing clinical trial actually by the pharmaceutical industry to find the COVID-19 medication. Now, they're not sampling the whole US. They use volunteers, sample of people that they can use to do the experiment and come out with the result about the drug, vaccine, or whatever they're looking for. Now, but how do you choose the minimum sample size you need? If the sample size is too big, it might be too expensive to run the test or do the experiment. If it's too small, then the results may not be applicable to the entire population. You will get inaccurate results. So what is that minimum sample size that you can have within your be within your budget, and at the same time got a result that can be generalized to the entire population? So to do that, we use a formula for the minimum sample size. I'm going to write the formula here. The computational formula is computational formula for minimum sample size is, I'm going to put, since we don't have, this page doesn't allow us to put the formula, directly. Some it allows to put some, not all. So I'm going to take you to that page where I can put the formula in and then bring it back to this workbook. Formula is this: N, that's minimum sample size, minimum sample size, and equals, you're gonna have this, and put it this one, put this one first. This one, that's why I like this page, to allow you to put the correct formula there, equation. So you're gonna put this right, and then we have Z alpha over 2, Z, okay, alpha over 2, okay, times the standard deviation, okay, divided by the error margin, and you square all the results. So this is the formula we use for calculating the minimum sample size. So let me paste it there so we can try one example there. Okay, sorry, my mistake. We're here. Okay. So let me take you to this page so we can now put the formula in. Okay, right here. So I can make it bigger. So with this formula, you can find the minimum sample size that is a true representation of the population. So let me move it to the next page so we can try another one example. It says here. So of course, you know that the Z alpha over 2 is the critical value, which is given. The critical values, I have it at the top. You can see the table right here. And that was the first thing I showed you how to calculate right here. Critical values, Z alpha over 2 for different confidence level. Now, for the standard deviation, the question will give you this population standard deviation. And then the error, of course, the error margin, it will also be stated in the question. For example, if you look at this example here, now it says solution. Give me 1 minute, let me check something in my book. I see use papers to write. Yeah. Okay. Okay, got it. So it says it is desired to estimate this mean number of chocolate chips per cookie for a large national brand. How many cookies have to be used, have to be sampled to estimate the true mean number of chips per cookie within 2 chips? That means if you're going to make a mistake, you're going to cost you only 2 chips. So that means our error is 2. With 98% confidence. Okay. So that means our error is 2 chips. Sorry, 2. Or it says within 2 chips. Okay. Then the alpha over 2. Alpha over 2 for 98%. So 98%. I think I have it here for you. Is right here. 2 point, actually 2.3. I think I have the 2.33. Yep, 2.33. So change this to 2. So this is an error 5 is now 2.33. 98%. 2.33. We have it right there as 2.33. Then standard deviation is given as 10.1 chips. The standard deviation is given as 10.1 chips. But always do. I don't know why you always do that. That's why I prefer the other page to put the formulas. Okay. So with this, you can now plug all this in your this formula here to get the minimum sample size. And the answer always go round to the next number. Okay. So that means I'm taking you back to our, let me write this down before I take you back. Error is 2, and the alpha over 2 is 2.33, and standard deviation is 10.1. So let me take you to that page so we can complete this. In that page now. So the minimum sample size now becomes, I have the formula here already, equals, I'm gonna have this. Okay. Then I'm gonna have put it for case right here. We got for the z alpha over 2, we have 2.33 times standard deviation of 10.1 divided by error of 2, then square our result. Okay. Now this we can put in decimals. Okay, we have 2.3. Okay, let me take it to decimals. Okay, we got let's clear this. So we got 2.33. Sorry, yes, 2.33. Okay, we have over 2. At the top here, we're gonna have 2.33 times standard deviation of 10.1. 10.1. Okay. Close it and then square it. See, give us 138.45. 138.45. So let me put that in and then share it with you. Get 138.45. So now in algebra, this is going to be 138 because 4 is not up to 5. But here we're not interested in that. We're looking at go to the next number, 139. So that is what we need, 139 samples. So we need 139 samples of cookies. Okay. Okay, I don't know if you can see this. Let me make sure you can see this. Oh, okay, it's right here. So you want 9 samples. Okay, that's what you need. So you get the error. The error is given on the question. And then the alpha over 2 you can get from the table. Then the standard deviation, we plug them in, you see we have 139 samples. So that's how you find the minimum sample size. Any questions? Questions? So that means right this one here, you can try this at home when you have the chance. Here, in that case, you get the Z alpha over 2 for 95%. They give you the error of 15 cents. That means if you're going to make an error, it will cost you only 15 cents. And the standard deviation is 6 cents. So you can just plug it in and get the minimum sample. Now, let's take a short break, come back and finish up. And when we come back, we'll start from here. Confident interval for the mean for small samples.
What time do you want us to come back?
Huh?
What time?
2:30. 2:30.
Okay, 10 minutes break.
Yeah, 10 minutes break. We'll be back. Yeah? I see you in that time. 2:30. We begin. Okay? Enjoy your break. Okay. Glad we are back. Hope you're all in there. Mr. Taylor, you there? Hello?
Yes, Professor, I'm here.
Yes.
Adona, are you there?
I'm here.
Miss Owotutu, you there? I'm trying to put your name, attendance. So let me see. Mary, not there. Okay. Elizabeth, you there? Elizabeth, you there? I think we'll ask that one. Go to this here. Okay. Now let us continue from where we start. Now, I like I mentioned, I said before we went for the break, we'll come back, we start from the one we just did, the confidence interval for the mean when the sample size is large and the standard deviation is known. But this one, we don't know the value of this population standard deviation. So we use sample standard deviation for that. And the sample size is small. In statistics, we say it's small when it is less than 30. And, so in that case, for this, we cannot use the table of normal distribution that we normally use. We need a different table. It is called the student T distribution. This table had an interesting history. In those days, there's a competition between industries. A competition. So people that work for industries, if they do any research, they're not allowed to publish their findings because their competition might steal that their findings and use it to, grab the market share from them. So this researcher, I think his name is William W.S. Gosset, Gosset. So he was doing a research in Europe. I know he worked for one company that make alcoholic drinks. They call it ale. I have not seen it in America here. They call it ale. Let me take you back to where we are. Okay. They call it ale. I mean, the kind of ale I see in America, the one that I buy in a grocery store, it doesn't have alcohol. But in Europe, ale is very popular. It's an alcoholic drink, ale. So Gosset worked for the brewery where they make ale. So he was doing some kind of research, and then he developed this table that they did. But he cannot publish it. Remember the company they work for prevent them from publishing their findings, so that because they're afraid that their competitor might steal their trade secrets, So he decided to publish it anyway. So he used a different name. He used the name student. That's how we get the student quality. He got the name student T distribution. So we use it when the population is small and we don't know the value of this population standard deviation. So we used it. Now, if you look at the table, it is based on DF. What they call DF means degree of freedom. So I'm gonna take you back to this place. It's based on degree of freedom. So sample size and degree. So degree of freedom is degrees of freedom. Or you can call it DF. And for this is oh, excuse me, you see that I have too much D here. Yeah. So for this we have DF, and for this confidence interval is n-1 will give us the degree of freedom. N-1, n is the sample size. Now for the using this table for finding confidence confidence interval calculation, we have A prime when it is only one side point is, but we have A double prime. You can see the two lines like look like an inverted comma. Prime. That means two sides, left side or right side. So that's the one we'll be using for confidence interval estimates. So let us find out. So let's see. So that means we find our critical value using the T distribution table, not the Z anymore. Let's see how this works. Let me close some pages. Some pages are just blocking us from here. Close this, and then, okay, good. Now, let's see how it works. First of all, let me show you how to find the critical value from the table. Now, unlike the other one we did, where the critical value is constant for each confidence level, here, see, no matter what the sample size is, the critical value is always the same for Z value. For the T table, it is not. It varies with sample size. See, sample size varies, changes. When the sample size change, it changes as well. Okay, like here, when the sample size is 6, the critical value will change to something 57, even though it is the same confidence level. Let's do an example so that you can understand what I mean. See here, they find the confidence level for N22. Solution. Sorry, so find the 95% confidence level for N22. That is just like saying find the critical value given the confidence level of 25%. So I have it right here. Excuse me. Let me make it bigger so you can see it better. Okay. Okay. Now here N is 22. N equals 22. So that our degree of freedom will be df equals n minus 1, which is 22 minus 1, which is 23. Okay. Now, which means that the z alpha over 2, z alpha over 2 as the critical value. Critical value will be, you look for it under 23 degrees. Oh, actually, this is 21, not 20, 21. Under 23 degrees of freedom. Okay. Under 21 degrees of freedom. You look for it on the table. So let's go to the table and find out the student T distribution table. So remember, we're using this part, alpha prime prime. Remember that if you say 95% here, chance of being wrong is 5%. You will look for 5% here. Look at 5% right here, 0.05. Then this is the degree of freedom here. You go under 21 degrees of freedom, which is right here, 21. Under 5%, so you have 5% under 21 degrees of freedom right here. Follow it, you can see right here. 2.080. Okay. Excuse me, I mean, take it back. Okay. That'll be 2.080. That answer the question. Any question on that? Any question?
No questions, Professor.
Now, you can see that if for the Z table, no matter the sample size, the critical value remains the same for the given confidence level. But here, it's not the same. For example, if I change the sample size, suppose the sample size is N equals 19, you will see that the degree of freedom, that the critical value will change to something else. See? That means our alpha, that means the alpha over 2, degree of freedom in this case will be 19 minus 1 equals 18. So the critical value is z alpha over 2, z alpha over 2, okay, will be, now you can go to that table again. See the same confidence level, but now critical value will change because of this. That's basically why it is called degrees of freedom. You know, so the alpha over 2 for 18, you go to that table, 18, for say the same confidence level of 5%, 0.05 for 18 is right here. 2 plus equal to 18 right there. See 18, 2.101. Okay, you can see 2.101. See, so that basically, so I just show, this is the actual question here, and I just want to show you, use this example to show you that when the sample size changes, the critical value change, unlike the Z table. Now, let's do one more example here. Suppose you have 99% confidence they are looking for. In this case, we have solution. Okay, N is 18. 18. Sorry, 18. Okay, and sample size is 18. Okay, and which means that the degree of freedom will be 17. DF equals N minus 1, which is 18 minus 1, which is 17. So that's Z alpha over 2. Z alpha over 2 by 2 will be, you look for this on the table of normal distribution, sorry, of student T distribution. 99 will be, so means a chance of being wrong is 1%. Look for it under 1%. Alpha A prime prime under 1%. You go to 17, you're gonna be right here. Wait to see, right, 17. 2.898. 2.898. 2.898. So that's how to use student T distribution table. Now, you use it, remember, when the sample size is small, as it's less than 30, and we don't know the value of this population standard deviation, in which case we use the sample standard deviation. Now, the formula is still the same. So that this time around we're using standard population sample standard deviation and then sample sample mean of same sample mean that we used in the previous calculations. So we're using sample standard deviation and also the T table. That's us. So let's see how this works in this example here. Here I explained when to use Z or T table. Okay. Now let's do the last example we have for today. It says here, okay. Say say a sample of 6 college restaurants. See, 6. See, the sample size is small. 6 has an average weight of 276 pounds and the standard deviation of 12 pounds. See, only 6 restaurants were sampled. Now, find the 90% confidence interval for the true mean weight of all the wrestlers. Now, if a coach claimed that the average weight of the wrestlers on the team was 310 pounds, would the claim be believable? So we follow the same process, except that we are now this time around the sample size is small, so we are using T distribution table, and also we're using the sample standard deviation. So here, let's see solution. In this case, sample size M is 6, only 6 people. So I'm going to make a sample size. So we're going to use T distribution table. Make it bold. And we don't have a population standard deviation, but we have a sample standard deviation of 12 pounds. So, but the sample mean is 276. So let me go where I can get a character for X bar. Okay. Sample mean of X bar. I think it's 276, I believe. Let me see if I can I think I have an example, something similar here. Okay. Yeah, 276, 276, 276. Okay. Now I'm gonna take it from here and paste it on our workbook, our main workbook. So you can see that it is the same process. Now, we are not using the population standard deviation. We are using the sample standard deviation, which is S. We use S, small s, to represent population standard deviation. S equals 12 pounds. Now let us find the critical value. Z alpha over 2, Z alpha over 2, have Z alpha over 2. Over 2 equals, oh, but before I can get that, we need to get our, see, N is 6. So that degree of freedom will be N minus 1, which is 6 minus 1 equals 5. So that Z alpha over 2, our critical value, we look under 5 for 90%. If you say 90%, it means that our chance of being wrong is 10%. So let's go to the table. Before then, let me write it down so I can know what I'm looking for. On the table, we have degree of freedom is 5, and its alpha is 90%. Okay, so that the alpha over 2 will be, let us find it on the table of T table. 90%, that means your chance of being wrong is 10%. Look at 10% right here. Under 5 degrees of freedom. See 5 right here. See? It's 5 degrees of freedom. 2.015. 2.015. So I'm going to take it back to our main workbook. 2.015. 2.015. Now let us find the error margin. Again, some of the characters for finding it are not in this workbook, so I'm going to take it to the other workbook. But the error will be the same way we calculate error. But this time we're using T table. So we're going to use, instead of Z alpha over 2, we're going to use T. Oh, you know what? I put Z alpha over 2 here. It should be T alpha over 2. Sorry. T alpha over 2. Okay. T alpha over 2. So this is because we're using the T table. So let us go there and look for value of, we found it already. So the error margin will be T alpha over 2 times standard deviation over root N. So it's going to be error T alpha over 2, which is 2.1015 times standard deviation over root N, which is 2.015 times our standard deviation is given as 12 or root 6. Okay. Now I'm going to take you to that table, to that workbook, work it out, and then we'll come back and paste it right here to find our confidence interval. Okay. So we have it here. Error margin, same error margin E equals, so instead of Z alpha over 2, we have T alpha over 2. Okay. T alpha over 2.
Professor, are you going to send the recording to us?
Oh, sure. I sent the one I did last week too. You received it, right? Hello?
Yes, I received it, but I haven't opened it. It's okay. I'll open it when I'm ready.
Okay, no problem. So 10 times standard deviation divided by, this time we're talking about sample standard deviation. So it's going to be S over the square root of N, like before. The square root of N. Okay. And this gives us equals T alpha over 2. We got it as 2.015 times we have the standard deviation over root n. 12 is the standard deviation, square root of n. Our n is only 6 restaurants. We are samples. Now we can get this from Desmos. So I'll take you to Desmos, so we can do the calculations in Desmos. And so you have this as 2.015, 2.015 times, parenthesis, standard deviation of 12 divided by the square root of 6. Okay. That gives us the answer we need. 9.87. 9.87. 9.87. We have it right here. So I'll take you back to your the workbook, from where we go to the next the main workbook. So let me copy all this and put it on our main workbook. Have it. Okay. This is the main workbook right here. Then from there we can now proceed to find the confidence interval. See, we have once you have your error margin, you're almost done. That's it. So that means you subtract the error on the left side, add the error on the right side. Now, the 90% confidence interval here, the 90% confidence interval is given by, okay, the formula. Like I said, it's the same process. The only thing that changed that now we are using a T table and sample stand. So it's the same process. Error S bar minus error is less than the mean. I want to copy it so that I can paste it there. Because it's the same formula. So you have S bar minus error. Okay. Equals to the mean is less than the mean. Okay, we'll have it right here. S bar minus error. So our error is 9.87. So let's give us some. S bar is 276. 276 minus 9.87, less than the mean that we're trying to estimate. Okay, less than. On the right side, I have 276 minus error of 9.87. We give us the confidence limit. Let's do it on the Desmos. 276. But it's a point that I put comma instead of point. So 276. I got 276 minus 9.87. So in Desmos, we have 276. Okay. 276 minus 9.87 is 266.13. That's the mean. Now, if you put it plus on the right side, because on the left side you subtract, on the right side you add, 285.87. So now let me put it back in, and then we can finish our work. So that gives us 266.13 pounds, less than the mean that we're trying to estimate. Okay. And less than, on the right side, we have 285.87. So our conclusion here will be that we are 95% confidence. Conclusion. Okay. We are 90% confidence, because it says to estimate 90% confident interval for the true mean weight. Okay, that's confident that the true mean weight of the wrestlers, of all wrestlers, lies between 266.13 pounds, 266.13 pounds to 285.87 pounds, 285.87 pounds, based on a sample of 6 wrestlers. Questions? Any questions?
No question.
So now, so the rest you can practice. Now, part B says, part B, it says, based on our results, if a coach claimed that the average weight of wrestlers on the team is 310 pounds, will that claim be believable? Of course, it won't, because solution, no, because 310 pounds falls outside the interval of 266 pounds. It falls outside the interval of 266 pounds to 285 pounds. Okay, so that claim, it cannot be believable. If the claim is, let's say that the claim is 280 pounds, that means it can be believable. So the same way that you do the rest of them, like here, you just follow the same process. Here, they give you the numbers. So like you have 1, 2, 3, 4, 5, 6, so that n is 7. So just use a calculator. Or calculator will be difficult for you to find this. You can find the mean here with a calculator, but the standard deviation might take you a longer time. So you can say use Excel to find the mean and the standard deviation, then follow the same process, and then you get the answer. So you can see that it's not hard like that. Subtract the error on one left side, add the error on the right side. Now, you know you're gonna do a project in this class. So next week I'm gonna put the project, make it available so that you can start on time to finish up before the end of the semester.
Project. So the project is gonna be on this, or how?
Yeah, you're gonna do a little bit of here and some other things we done in the class. Yeah, I'll make it available. Okay, next week. Any question before we close for the day?
That's what they call is killing me.
What's that again?
I say all this assignment is the one that is killing us.
but you're still talking, so you're not dead yet.
You can see that the brain is not working.
Well, at least, like I said, you're still alive, so you're not dead.
I thank God for that.
So you're still.
So is it just 5 for us that are left with you now, or what?
Well, some show up later on, like send me email. I don't know. I work with what I have. Okay.
I know.
Yeah. So you cannot force them to be in class. it's all entirely their decision.
Right.
Mine is to teach it the right way, give you the opportunity to make
really doing
pass, and then
with the online mathematics. I mean, I think you are the best. I'm telling you.
I appreciate.
Some of my friends in other school, they had to drop their statistics because.
I know it's hard. It's hard for some people. Yeah. Some people, many people are used to coming to class.
Yeah, but you are doing a good job. Like you have a board, you are writing it down. I mean, it's like we are in class. You are very good in teaching this online.
Anything I can do for you, all I can do. That's what I'm here for.
Yeah, because it's like you are writing on a board. You are writing it out. You are explaining it. You know. It's really good.
Thanks for the compliments. So, like I say, if we don't have to have a class next week, I'll have to confirm with the school. If you're going to, if you're not going to have it, then, but usually we don't have Saturday classes on Thanksgiving weekend. So I will let you guys know. Okay, and that means if you don't see next week, I'm wishing you all to have a nice Thanksgiving. Okay.
Okay.
Thank you, Professor. You too.
Bye bye. So I'm
Real
gonna.
fast, when is the project due?
Well, I'll let you know when I put it next week. Okay.
Okay.
Usually my project are due on the last day of class.
So the assignment 14, 15, and quiz is due tomorrow evening, right?
No, quiz is due tomorrow, but 14 and 15, I think I made a due date. When did I put the due date? I think let me pull up the screen. You're gonna be on the screen. Let me pull up the screen. I'm gonna go to your class again. BCC, and from here I can go faculty and staff. Okay.
Quick question while you're looking that up. Is there a way you can release it a little bit earlier than next week? Because like it's a lot going on in these next couple of weeks with these classes ending right now. So I just want to know if I can get a head start on it.
You're talking about the project?
Yes.
Okay. In that case, I can release it this weekend and send a message. Okay, maybe tonight, even now.
Thank you.
I can put it now.
Thank you.
Well, if you release it this weekend, you still have to give out the due dates, like what is supposed to be, right?
Yeah. So, yes, I'm gonna do it right now. But let me show you. Let me show you this one first. The announcement about what is due this week. Okay, so you can see my announcement for week 13. Yeah. So what you have due this week, you have 14 and 15 is due on the November 29th. So what is due this week? Tomorrow is the quiz 3. Remember, it have been there since last week. So and discussion 6 and 5 are due to 9th. So now let me make the project. Oh, the project is actually I have to put the questions together. Just tomorrow, okay? Tomorrow night I'll make it available, okay?
Okay.
I have to put the data that you're gonna use for it together, okay?
Thank you.
You're welcome. All right.
Did you say the discussion 5 and 6 is due tomorrow? Because it says that it's due 29.
It's due 29, not tomorrow.
Oh, okay. So it's just the
only thing that is due tomorrow is the quiz 3.
Oh, okay.
So it's just quiz 3 that's due tomorrow?
Yeah.
I think we got some homeworks due tomorrow too.
What about the Excel?
Yeah, those are last week homework. So remember I put those students, I told you that some homework are due tomorrow. I told you last week, remember? So those ones that are due tomorrow, try and finish all of them, okay?
So is it the Excel assignment 5 that's due next week?
Yeah, I think it's due next week. That one too, yeah. That one, let me let us not guess. Let me open it so you can see. Still assignments. See, there's one that is due tomorrow. It has been there since 2 weeks ago. Remember? I can show you the
assignment 6.
No, 5. I'm talking about 5. 6 is due in December, right? You know.
5.
Yeah. All right. I enjoy your weekend, okay?
Okay, thank you.
Thank you, you too, Professor.
All right.